Welcome to all. I am A. Mary Odilia Tina, Assistant Professor, Department of Computer Applications, St. Joseph College, Cuddalore. Today I am going to explain about threads in distributed operating system. In traditional distributed system, each process has an address space and a single thread of control. In distributed operating system, it is possible to have multiple threads of a control within a process. Now see the figure A. So in this figure A, each we can see a machine with three processes. Each process has its own program counter, own stack, own register set and own address space. Now look at the figure B. In this figure B, we see a machine with one process. This process contains a multiple threads of a control. So this is called as what? Threads. And threads are also called as lightweight process. It is the smallest unit of the processing. Each thread runs sequentially and has its own program counter and stack to keep track of where it is. The main advantage is threads are sharing CPU. That is, it shares common memory area. So it shares a common buffer cache. That is common address space. Anyway, we can say it. This is one of the main advantage in a thread. Then threads are independent. If any thread crashes, it does not affect other threads because threads are independent. And another advantage is threads does not block the user because the threads are independent, so it performs multiple operations at the same time. The threads can be any one of the several states, that is running, blocked, ready or terminated. There are two ways to implement a threads package. One is by using user level thread and the second one is kernel level thread. What is user level thread? So the user level threads are implemented by the user level software. So it is basically created and implemented by the thread library, which OS provides as an API for creating and managing the synchronizing threads. API means Application Programming Interface. Then the user level thread is faster than the kernel level threads. It is basically represented by the program counter, stack, register and PCB. Next, kernel level thread. The kernel level threads are also a kinds of thread which is handled directly by the kernel thread management. Then the operating system support the kernel level thread. Each kernel level thread is a self-organizing and the kernel provides each thread with its own context with information about the thread status such as name, group and priority, etc. So this is the diagram for the user level thread and kernel level thread. The first diagram, that is in figure A, shows the user level thread package. So in the user level thread, there are multiple threads are executed in the user level threads to put the thread package entirely in the user space. The kernel does not know anything about them. One of the advantages, an operating system does not support threads. For example, Unix operating system does not support user level thread. Now in figure B, it shows kernel level thread. Here, no runtime system is needed. Instead, when a thread wants to create a new thread or destroy an existing thread, it makes a kernel call to perform creation and destruction. To manage all the threads, kernel has one table per process with one entry per thread. Each entry holds the thread registers, state, priority, and other information. Now we'll see the difference between user level thread and kernel level thread. The first parameter is implementation. I already said user level threads are implemented by user and kernel level threads are implemented by operating system. The second parameter is recognized. The operating system does not recognize. In the kernel level thread, it is recognized by the operating system. Then context switch time. Here the less context switch time, but in kernel level thread, more context switch time. Then hardware support. Context switch requires no hardware support. Here kernel level thread, hardware support is needed. Blocking operation. If one user level thread performs a blocking operation, then the entire process will be blocked. But in kernel, the thread performs a blocking operation, then another thread can continue execution. Multi-threading. Multi-thread applications cannot take advantage of multiprocessing. Here kernels, the threads can be multi-threaded. If the server had multiple threads of control, a second thread could run while the first thread was sleeping. Next parameter is creation and management. User level threads can be created and managed more quickly compared to kernel level thread. Operating system, I already told. User level thread support operating system. Kernel level threads operating system specific. Thread management. The thread library contains the code for thread creation, message passing, thread scheduling, data transfer, and thread destroying. But in kernel level thread, the application code does not contain thread management code. It is merely an API to the kernel mode. The Windows operating system use this feature. So the example for the user level thread is Java thread POSIX. In the example for the kernel level thread is Windows Solaris. Then the advantages of user level threads are it is very simple and quick to create. It can run on any operating system. It is better than kernel level thread, and the switching between threads does not need kernel mode privileges. The advantages of kernel level threads are scheduling multiple threads that belong to the same process on different processor is possible in kernel level threads. Multi-threading can be there for kernel routines. When a thread at the kernel level is altered, the kernel can schedule another thread for the same process. Some of the disadvantages of user level thread are multi-threaded applications on user level threads cannot benefit from multiprocessing. If a single user level thread performs a blocking operation, the entire process is halted. But in kernel level thread, transferring control within a process from one thread to another necessitates a mode switch to kernel mode. Kernel level threads take more time to create and manage than user level threads. Next, the memory management. In user level threads, each thread has its own stack, but they share the same address space. In kernel level threads, have their own stacks and their own separate address spaces, so they are better isolated from each other. Then fault tolerance is one of the important technique in the thread. Here, the user level threads are less fault tolerant than kernel level threads. Kernel level threads can be managed independently, so if one thread crashes, it does not affect the other thread. Then the next parameter is resource utilization. User level threads don't take full advantage of the system resources. as they don't have direct access to the system level features like input-output operations. In the kernel level thread, it can access to the system level features like input-output operations. So it can take full advantages of system resources. Then the next parameter is portability. Here the user level threads are more portable than kernel level threads. Kernel level threads are less portable than user level threads. So these are the difference between the user level thread and the kernel level threads. Thank you.